Let me start with a confession. The first time I went looking for gold in a river, I was 100% sure nature was about to hand me a retirement plan, and 0% sure what I was actually doing. I had the confidence of a guy who watched 3 videos, bought a pan online, and suddenly felt spiritually connected to the word prospector. I walked up to the water like, "All right, river, pay up." And the river was like, "Sure, buddy. Here's sand. Here's more sand. Here's a rock that looks like a potato. Congratulations." That's when I learned the first rule of gold in rivers. If you don't understand why gold is there, you'll spend your whole day washing gravel like a medieval laundry worker. For nothing. So today we're talking about something that sounds simple, but it's basically the foundation of real-world gold hunting and geological thinking. What is placer gold? And why do rivers and streams even have gold in the first place? And I'm not going to explain it like a textbook. I'm going to explain it like a human being who has wasted time, made mistakes, and slowly realized nature is running a very clever system. By the end of this video, you'll understand what placer actually means, how gold gets from solid rock into a river, why rivers don't spread gold evenly like butter on toast, why one spot can have nothing, and a few meters away can have heavy black sand, concentrates, and maybe that beautiful little yellow dot. And along the way, I'll throw in the kind of real talk nobody tells beginners. Most rivers don't have gold. They have a few specific spots that trap it. Everything else is basically a gold-themed cardio workout. Now, quick note. This is educational content. Local laws matter, private property matters, safety matters. Don't trespass. Don't mess up the environment. Don't do anything reckless. I'm here to help you understand geology and natural processes, not to turn you into a villain in a park ranger's story. All right? Let's begin with the big idea. Placer gold is secondhand gold. There are 2 main stories gold can live through in nature. Story number 1, gold is still in the rock it formed in. That's called lode gold. Gold locked inside veins and ore, often with quartz, sulfides, and a whole complicated family history. Story number 2, gold has broken free from that original rock and got moved by gravity, water, and time. That's placer gold. So placer gold is basically gold that has been recycled. If lode gold is gold at home, placer gold is gold that moved out, got pushed around by life, lost some friends, and ended up sleeping in a riverbed. Placer gold can show up in riverbeds and stream gravels inside cracks in bedrock behind big boulders in ancient river channels that aren't even rivers anymore. Beaches, yes, waves can concentrate heavy minerals too. Desert washes after flash floods. Placer doesn't mean river specifically. It means concentrated by sediment movement, usually water, sometimes wind, sometimes gravity. Now here's where it gets interesting. The river doesn't create gold. The river sorts gold. Gold doesn't form in the river. The river is not a gold factory. It's more like a massive natural sorting machine, and it sorts material based on one thing above all: density. Gold is insanely dense, about 19.3 grams per cubic centimeter. Most common river gravel, quartz, granite bits, normal rocks, sit around 2.6 to 3. So gold is like that one friend in a swimming pool who just sinks straight to the bottom and ruins everyone's fun. If you've ever tried panning, you already felt this. When you swirl the pan, light stuff moves fast. Heavy stuff stays. That is literally the whole placer concept. Water moves everything, but it separates everything. And the heavier something is, the more it wants to settle down and stay down. So the river is constantly running this process. Pick up sediment, move sediment, drop sediment, move it again, drop it again, repeat for thousands of years. But during all that movement, gold behaves differently than normal rock. Gold is not just heavy, it's also malleable. It bends instead of shattering easily, resistant to corrosion. It doesn't dissolve like many minerals, capable of flattening into flakes and traveling in a unique way, so gold survives and accumulates, while a lot of other stuff breaks down or gets washed away. But that still leaves one big question. If gold starts in rock, how does it get into a river? This part is the origin story, and it's important, because if you understand how gold escapes rock, you can start thinking like geology thinks. Gold is often formed deep underground through hydrothermal processes, hot fluids moving through cracks, depositing minerals in veins. Over time, tectonic forces can uplift those rocks. Mountains rise. Rocks that were once deep underground end up near the surface. Then the surface does what the surface always does. It destroys everything. Weathering is basically the world's slowest demolition crew. Water gets into cracks, freezing expands. Cracks heat, cycles weaken minerals. Plant roots wedge into fractures. Chemicals slowly alter and break down rock storms. Tear material away. Gravity pulls it down slope. And as that host rock breaks down, any gold inside it becomes free particles. At first, that gold might sit in soil. Then rain washes it downhill. Then streams pick it up. Then rivers move it. So gold is like that one stubborn item that refuses to leave your pocket until you throw your pants into the washing machine. Mountains and weathering are the washing machine. The river is the spin cycle. Now here's the part that most beginners misunderstand. Gold doesn't travel like sand people. Imagine gold flowing downstream like everything else, but gold is heavy. It behaves more like a bowling ball in a kiddie pool, a coin dropped into a fast-moving gutter, a weight tied to a string being dragged through gravel. Sure, during floods and high-energy events, gold can move, but most of the time, gold isn't cruising. It's hiding. Gold moves in short jumps, then rests. It gets trapped in places where the river loses energy, or where the flow creates a natural trap. And this is why you can scoop 10 pans from the wrong spot and get nothing. Then take one pan from the right spot and suddenly start breathing differently. You know that moment? That little flash of yellow. Your brain instantly goes, "Oh, so it's real." Yeah, that. So why do some rivers have gold and others don't? This is where geology becomes brutally honest. A river can only have placer gold if there is gold somewhere upstream or nearby in the drainage area. The river has enough energy at some point to move sediment. There are trap sites where heavy materials can settle. If any of those are missing, your pan is just a very emotional kitchen utensil. Some rivers drain areas with no gold-bearing rocks. Some rivers drain gold regions, but the gold is extremely fine and dispersed. Some rivers have gold but no good trap sites, so it's spread thin like sadness. And some rivers, especially those that have a history of repeating floods, changing channels, cutting into old gravels, can create serious placer deposits. So gold in rivers is not magic, it's source plus transport plus concentration. Remember that like a mantra: source, transport, concentration. The fun part? A river is a moving puzzle. Rivers are dynamic. They bend, cut, deposit, flood, shift channels, carve down to bedrock, and sometimes abandon their own old beds. A river you see today might not be the river that deposited the gold you're trying to find. Think about that. You could be standing next to water that looks perfect, but the real gold is sitting in an ancient channel 10 meters away under soil, because the river moved centuries ago. That's why placer gold can show up in weird places. Terraces above the current river, old gravel bars now covered in vegetation, dry stream beds, benches, and layers of compacted gravels, cracks in exposed bedrock far from pretty water. So if you're only hunting the obvious spots, you might be missing the real story. And yes, this is exactly why geology is addictive. It turns a simple river into a detective novel. Now, in the next part, we're going to get practical in a brain-practical way. What actually makes a good trap site? Why inside bends and behind boulders matter, how black sand fits into this, what bedrock does that gravel can't, and how the river's energy changes create concentration zones. And I'll share the single most useful mindset shift I ever learned. Stop asking, "Where's gold?" and start asking, "Where would a river drop the heavy stuff?" Because gold doesn't want to be found, it wants to be stable, and the river is constantly deciding where stability exists. All right, let's continue. In part 1, we agreed on one painful truth. A river is not a gold vending machine. It's a sorting machine. So now the real question becomes, where does a sorting machine drop the heavy stuff? Because if you understand that, you stop being the person who randomly pans pretty spots, and you become the person who reads the river like it's leaving you clues on purpose. And I'll be honest, rivers are not subtle. They're just dramatic. They scream their energy changes everywhere. They just do it in a language most people ignore. So let's translate the one rule. You must tattoo on your brain. Gold settles when the river loses energy. That's it. Not when the river looks nice. Not when the water is clear. Not when the spot feels lucky. Gold settles when the force of the water is no longer strong enough to keep heavy particles moving. So wherever the river slows down, even slightly, it starts dropping its heavy minerals. Gold black sand, magnetite, hematite, ilmenite, garnet. Heavy sulfides, if present, other dense material. This is why black sand is such an important clue. Not because black sand equals gold automatically, but because black sand means the river has been concentrating heavies here. It's like the river leaving breadcrumbs, very dark, annoying breadcrumbs. And yes, black sand is the clingy ex of gold hunting. It shows up everywhere, sticks to everything, refuses to leave, and somehow still teaches you lessons. Gold does not spread evenly, it concentrates in traps. Imagine you pour a mixture of ping pong balls and lead shot into a moving stream. What happens? The ping pong balls float and travel forever. The lead shot sinks fast and starts collecting in low points. Gold behaves like the lead shot. So the river naturally creates trap sites. Ancient and trap sites fall into two categories. Temporary traps. Gold sites there for a while. Then a big flood moves it again. Permanent or semi-permanent traps. Gold can build up over long periods. Your job is to find the second type whenever possible, because temporary traps might give you a few flakes. Permanent traps are where pay streaks can form. Let's talk about the classic traps first. Trap number 1. Inside bends, but not for the reason you think. Everybody has heard, check the inside bend. And then they go to the inside bend and scoop the first sand they see and get nothing and declare the river fake. Here's what's really happening. On a curve, water moves faster on the outside bend and slower on the inside bend. That creates erosion on the outside and deposition on the inside. So yes, inside bends are deposition zones, but gold isn't deposited evenly across the whole inside bend like someone sprinkled it with a shaker. Gold tends to settle in the lowest energy microzones inside that bend, often where the current first starts slowing down. Gravel transitions into sand, there are ripple patterns or compact layers. Heavy mineral streaks appear, the riverbed has sudden depth changes, so the inside bend is not the spot. It's a region, and within that region, you still have to find the actual trap. Think of it like a shopping mall. You don't just walk into a mall and grab the floor and say, "No iPhone here." You have to find the store. Inside bends are malls. Gold is in specific stores. Trap number 2. Behind big boulders, the river's shadow zone, boulders create a weird effect. When water hits a big rock, it splits and speeds up around it. But behind the rock, there's a lower pressure shadow zone where water slows down and swirls. That swirl can drop heavy minerals, so behind boulders can be great. But again, people mess this up. They scoop loose sand behind the rock and wonder why nothing shows up. The real gold often sits in the compact gravel layer right at the interface where loose material meets hardpack, or down in cracks if bedrock is present. Behind boulders is not a scoop, it's a dig. And if you don't dig into the heavy layer, you're basically just sampling the river's decorative topsoil. Also, not every boulder is equal. A boulder on a high-energy stretch might not trap anything because the water never truly calms down. But a boulder in a transition zone, where the river is already slowing, can be a serious gold trap. So remember, boulder plus slowdown zone charge potential. Trap Dar 3, natural riffles, where the river makes its own gold pan. You know those rippled gravel bars where you see repeating ridges? Those are natural riffles. Just like a sluice box uses riffles to catch gold, the river uses uneven gravel and cobbles to do the same thing. When water flows over a rough bottom, it creates small low-pressure pockets behind stones. Heavy material drops into those pockets. Over time, those pockets can collect heavies. This is why sometimes you see streaks of black sand in lines. That's the river literally showing you where heavies fall. And if you see black sand streaks, here's the move. Don't just sample anywhere near it. Sample the streak itself just downstream of the streak and the compact material under it, because those streaks form where the river loses enough energy for heavies to settle. They're basically a sign that says, hey, I'm sorting here. Trap Measure 4, bedrock cracks, the permanent storage. Now we're getting to the good stuff. If you want places where gold can build up and stay, you look for bedrock. Because gravel shifts, sand shifts, everything shifts. But bedrock is the hard floor. And bedrock often has cracks, crevices, joints, layers, rough textures, small potholes. Gold drops into those features and becomes much harder to move, especially if the crack runs across the flow. Because then the crack acts like a natural riffle. Gold drops in and gets wedged. So when you see exposed bedrock or shallow bedrock in a river, you should be thinking, where are the cracks and low points? Not, where's the sand? This is also why some of the best gold spots look ugly. They're not scenic. They're like a scratched old floor with broken tiles. Gold loves broken tiles. Trap Nurture 5, the pay streak, the concept that changes everything. Okay, this is the part that separates casual panners from people who actually find consistent gold. A pay streak is basically a concentrated line or zone where the river repeatedly drops heavy material. It can happen because the river's flow pattern is stable in that area over long time periods. The river repeatedly floods and reconcentrates bedrock shape, guides heavies into one path. The channel geometry creates a consistent, low-energy lane. Think of a pay streak like a heavy mineral highway, but it's usually narrow. Sometimes it's only a meter wide or even less. Sometimes it's just a specific crack line, and if you're panning randomly, you might miss it completely, because 2 meters to the left can be nothing. 2 meters to the right can be nothing. But on the streak, you're suddenly seeing color. So how do you find a pay streak? You sample systematically, not random scoops, not vibes-based digging. You take samples in a pattern, across the bar, across the bend, across the bedrock stretch. You look for where the heavies increase, you follow the clue. And yes, it's slower. But it's slower in the way that actually saves you time, because it prevents you from spending 5 hours panning useless sand, like a person trying to find Wi-Fi by sniffing the air. The black sand truth and why people misread it. Let's clear this up. Black sand is not good or bad. Black sand is a signal. It tells you the river is capable of concentrating heavy material in that spot. But black sand can be everywhere in some rivers, especially if the upstream geology produces lots of magnetite. So the real question isn't, is there black sand? The real question is the black sand concentrated in a way that suggests a heavy zone? Look for streaks pockets, layers dense bands sitting on compact gravel, black sand trapped in cracks. If it's just a light peppering across loose sand, that might not mean much. But if you see a thick, dense black layer sitting on hardpack or bedrock, that's a real clue. That's the river saying, I drop heavies here. Gold might be in the party, not guaranteed, but the party is happening. Quick personal story, because pain is educational. I once found a spot with gorgeous black sand. I mean, it looked like the river poured espresso grounds everywhere, and I got excited. I panned. I found nothing. I panned again. Still nothing. I panned a third time and started negotiating with the universe like, listen, I'm a good person. I recycle. I call my mom. Please. Then I finally did what I should have done from the start. I dug deeper. Under that nice black sand was a compact gravel layer. And right on top of that layer, suddenly I saw a few small flakes. Not crazy, not life-changing, but it taught me the big lesson. Gold sits in the layers, not the decorations. The top is often just the river's current mood. The bottom layers show the river's history. What we do next. In part 3, we're going to go deeper, literally and mentally. We'll talk about how floods move gold in jumps, why gold size changes downstream, what makes fine gold versus chunky gold, how old channels and terraces can hold gold away from the current river, and how to think like a geologist, source, transport, and concentration in real landscapes. And I'll explain why sometimes the best gold isn't even in the current water, it's above it. In places people walk past every day. Now that you know where gold likes to hide, we have to talk about something that makes people either very successful or very confused. Rivers have memory, not emotional memory, although some rivers definitely feel like they're holding a grudge. I mean geological memory, because the river you see today is just the latest version of a system that's been changing for a very, very long time. And the biggest force behind those changes is one thing: floods. If normal river flow is the river breathing, floods are the river going full beast mode. Floods are what actually move big gravel, reshape bars, carve deeper channels, expose bedrock, bury old layers, and, most importantly for us, rearrange gold. So if you want to understand placer gold distribution, you don't study the river on a calm day. You imagine the river during chaos. You picture water high, brown, violent, carrying logs like toothpicks and boulders like they weigh nothing, because that's when gold can move. But here's the key point. Gold moves in short jumps, not long cruises. Gold is heavy, so even during floods, gold doesn't travel like sand. Sand can move continuously. Gold tends to move like this, gets picked up briefly, slides or rolls. A short distance drops fast when energy decreases, locks into a trap, stays there until the next major event. That means gold migration is often step by step, not a smooth journey. So when people ask, does gold travel far? The honest answer is, some does, most doesn't. Large gold pieces, nuggets, rarely travel long distances unless the river is extremely energetic and the terrain is steep. They tend to stay near the source region. Fine gold, flakes and dust, can travel farther because it has more surface area relative to its mass, so it can be carried more easily in turbulent water. Which leads us to one of the most misunderstood topics: fine gold versus nuggety gold. and why your results feel random. Let's simplify this. Gold size in placer deposits is influenced by distance from the source river energy and gradient. How often flooding occurs, the shape of the gold, flat flakes travel differently than chunky pieces, and how much reworking the deposit has experienced. Near the source, you often find coarser gold, more angular pieces, sometimes attached to quartz or host rock, chunkier behavior. Farther downstream, gold becomes flatter, thinner, more worn, smaller, sometimes almost like glitter dust, because gold is malleable. Instead of shattering, it gets hammered and flattened by transport. So if you're downstream and you're expecting nuggets, the river will laugh at you. And not a cute laugh, a disrespectful one. Fine gold can still add up, but it requires different technique and different expectations. So the river isn't inconsistent. Your expectation is inconsistent with the geology. And that's actually good news, because once you understand what's likely in a given area, you stop wasting time chasing the wrong type of gold. The river has layers, and each layer is a different story. Placer gold isn't just on the bottom. It's often in specific layers called pay layers. Think of river deposits like a layered cake. Top, loose recent sand and gravel middle. Older compact gravels bottom. Bedrock or clay layer. Gold tends to work its way downward over time until it hits something that stops it. That stop layer can be bedrock clay because it's impermeable and traps heavies. Compact hardpan, a dense layer of cobbles that doesn't move easily. So if you only pan the top loose layer, you might miss the real concentration. This is why serious prospectors always talk about get to the bottom. Not in a motivational speaker way, in a stop being lazy way. Gold likes the bottom because gravity is undefeated. The most important concept, old channels and terraces. Okay. This part is where placer gold goes from hobby to geology puzzle. Rivers migrate. They move sideways over time, carving one bank, depositing on the other. They also sometimes cut downward, creating deeper channels. When that happens, the river can abandon older deposits. Those abandoned deposits become terraces, old river levels above the current river, benches along the valley walls, ancient gravel layers now covered in soil and vegetation. And here's the crazy part. Those old deposits can hold gold that is no longer in the modern river because the river already sorted it, concentrated it, and then moved away. So you can be standing near a modern stream with very little gold. And just above it, on a terrace, there can be an older gravel deposit with much better concentration. This is why you sometimes hear stories like, "I found gold nowhere near the water." And people think it's fake. It's not fake. It's geology. The water moved, the gold stayed. So if you want to find better placer deposits, you don't just look at today's river. You look at the whole valley history. Where did the river used to be? Where are the old gravel benches? Where are the terrace levels? Where does the slope flatten? Where do you see rounded river stones sitting above the current channel? Rounded stones above the river level are like the river's old footprints. The river is basically saying, I used to live here. And if it used to live there, it used to sort there. And if it used to sort there, you know where this is going. A simple trick. Learn to spot old river gravel. Old river gravel often has rounded cobbles, rounded chash water transport, mixed sizes. Layers of sand and gravel, sometimes cemented or compacted, sits above current stream level, might be covered by soil or vegetation. If you see rounded river stones far above where water currently flows, you should be curious. Because that's not random. That's history. Now, I'm not telling you to dig up hillsides like a cartoon miner. I'm telling you, think. Ask, why are these river stones here? If the answer is ancient channel, you found a new category of targets. Flood gold, why the best days can be right after chaos. Sometimes gold is reconcentrated after major flood events. Floods can strip off light material, expose bedrock cracks, create new bars, deposit fresh layers of heavies, so certain places can become hot after floods. But there's a catch. A fresh bar created by a flood might look beautiful, but could be mostly light material. Or it could be sitting on a pay layer. So after floods, sampling becomes even more important because the river just rearranged the puzzle pieces, and you need to test where it dropped the heavies. Personal commentary. Why people quit too early. Let me say something from personal experience. Most people quit not because there is no gold. They quit because they don't understand what finding gold actually looks like. They imagine big shiny nuggets, instant results, cinematic moments. Reality is often tiny flakes, patience, learning the river's pattern. Lots of nothing before something, and the emotional roller coaster of thinking you're a genius. Then immediately humbled by a pan full of black sand. But here's the truth. Once you get your first consistent signal, once you learn to find heavies repeatedly, you stop feeling lost. You start feeling like you're playing a game where the rules finally make sense. And that's addictive. Now we're going to do the thing that separates I watched videos from I can actually find gold. Because here's what most beginners do. They walk to a river, see a spot that looks nice, scoop some sand, swirl it around, get nothing, and then blame the universe. But the universe is innocent. The universe is just sitting there like, bro, you sampled the wrong layer, in the wrong place, with no plan, and you did it once. That's not prospecting. That's gambling with extra steps. So today we're talking about sampling, the most boring sounding thing that becomes weirdly exciting once it starts working. Sampling is not about hope. Sampling is about information. You are not there to find gold on the first pan. You are there to answer a question. Is the river concentrating heavies here or not? Because gold almost always rides with heavies. So if you can find the heavies, you can follow the trail. Let's build a simple system. The mindset shift: you're not hunting gold, you're hunting evidence. This is the most important thing I can tell you. Gold is evidence-based. If a spot has black sand concentrations, compact gravels, clay layers, bedrock cracks, natural riffles, a clear energy drop, then that spot deserves testing. If a spot has none of those and it just feels lucky, then congratulations. Your feelings are very cute, but they are not a geological tool. The river does not reward confidence. It rewards correct questions. So here's the correct question. Where would heavies drop in this specific stretch of river? Now let's talk about the practical sampling method, the 3-sample rule, because one pan means nothing. Never judge a spot from one pan. One pan can lie. One pan can be too shallow, taken from the wrong microzone, missing the pay layer by a few centimeters, contaminated by lighter material. So here's a simple rule. Take 3 samples before you decide. But not 3 random samples like a confused squirrel. 3 samples with purpose. Sample 1, the surface layer. This tells you what the river is doing recently. Sample 2, the middle layer. This tells you what has been sitting longer. Sample 3, the bottom layer, as close to bedrock, chalk clay, hardpack as you can safely get. This tells you what the river has concentrated over time. Then compare the heavies. If heavies increase as you go deeper, that's a good sign. If heavies disappear as you go deeper, that's usually a bad sign. And if all 3 are basically just light sand with no heavies, that spot is telling you no. And you should listen, because the river is brutally honest if you stop arguing with it. what you're actually looking for in the pan. Most people swirl the pan and stare at it like they're waiting for it to speak. Let me help. When you pan concentrates, you are not just looking for yellow. You're looking for black sand density. How quickly heavies settle streak patterns, the heavies line, where dense material gathers near the bottom edge of your pan. Microsparkles that don't behave like mica, because in early sampling, you might not see gold yet, but heavies will tell you if you're close. Think of heavies as the smell of food before you reach the restaurant. If you smell nothing, you're probably not near the kitchen. If the smell is strong, you keep going. Now let's talk about the most common sampling mistake. The beginner crime, sampling loose sand. Loose sand is easy to scoop, so beginners love it. But loose sand is often just the river's current, skin. It changes after every flood, every season, every storm. Gold tends to work down into compact layers, cracks clay bottoms, hardpack gravels. So if you're only sampling loose sand, you're basically reading the river's Instagram, not its bank account. You want the bank account. That's where the value is stored. So what do? You dig until you hit clay bedrock compact gravel, a layer that feels stuck. That's the layer worth testing. Reading microclues, the river talks in small details. Okay, now I'm going to sound like a crazy person, but stay with me. Rivers talk, not with words, with transitions. Gold likes transitions because transitions mean energy change. Look for 1. Gravel size changes. If you see a section where big cobbles suddenly become smaller gravel, the river is losing energy. That's a deposition zone. 2. Color changes: reddish-brown sands, dark heavy bands, rusty staining, black streaks. These can indicate mineral-rich zones, not guaranteed gold, but worth testing. 3. Texture changes. Loose fluffy sand versus compact packed gravel. Compact is usually older and more stable. 4. Natural steps in the riverbed. Little drops, ledges, small bedrock shelves. Heavies can settle above or below these. 5. Bedrock exposure. Any bedrock exposure is a giant neon sign that says, gold could be trapped here, especially if there are cracks running across the flow. A simple decision system: stay, move, or mark. Here's the system I use. After your sampling, you decide one of 3 actions. 1. Stay. If you see increasing heavies with depth, consistent black sand streaks, any gold color at all, even tiny bedrock cracks, holding concentrates, then you stay and test more precisely. 2. Move. If no heavies, no structure, no sign of concentration, everything is loose and uniform, then you move, no drama, no arguing. 3. Mark. If you see potential but conditions aren't ideal, like high water, bad access, or you couldn't reach bottom, then mark the spot and return when conditions improve. This is what smart prospectors do. Dumb prospectors keep panning until the sun goes down and then say, rivers are scams. No, bro. Your strategy was a scam. The cross-river scan, how to find a pay streak without guessing. Remember pay streaks from part 2? Here's the simplest way to start locating one. Instead of sampling in a straight line downstream, do this. Sample across a bar or across a bend in a rough grid. Think of it like scanning for signal. You're looking for where heavies are strongest. Once you find the strongest sample point, you sample around it. That's how you home in on a pay streak. It's not romantic. It's not cinematic. It's effective. And it's exactly how you stop wasting time. Tools talk, a little opinionated, sorry not sorry. Let me give you a quick personal rant. There are people who think buying gear is the same as buying skill. It's not. A pan and a shovel can teach you more than a $1,000 setup if you use them correctly. That said, a few things actually matter. A good pan you're comfortable with. something to classify material, even simple screens, a way to break compact gravels safely, a small snuffer bottle if you're actually collecting gold, and most importantly, a notebook or phone notes to record what you found, where. Because gold hunting without notes is like trying to cook without remembering ingredients, you will repeat mistakes and the river will happily let you. Mini story: the day sampling saved my sanity. I once spent half a day in a beautiful spot, clear water, perfect bend, scenic as a postcard. I got nothing, not even heavies. Then I moved 30 meters to a boring section near an ugly pile of cobbles. I took 3 samples. The bottom layer had a thick black sand line and tiny specks of color. That's when I realized nature is not aesthetic. Nature is functional. The best spots don't care if your camera likes them. They care if physics likes them. Now we're entering the zone where the river stops being a friendly teacher and starts being a sneaky professor who grades your homework with sarcasm. Because by now you already know the obvious traps. Inside bends behind boulders, natural riffles, black sand streaks. But the places that produce consistent gold, where a pay streak can actually develop, usually have something extra. They have a bottom that can hold gold, not just drop it, hold it. And that bottom is usually one of these: bedrock clay, hardpack, das cemented gravel, a false bottom created by tightly packed cobbles or combinations of all of them. So today, we're going to talk about the traps that don't just catch gold for a day. They can catch gold for years. The stop layer concept, the most important thing you'll ever learn. Gold wants to sink, so in a river deposit, gold keeps working downward until it hits something it cannot pass through easily. That something is called a stop layer. If you understand stop layers, you stop panning random sediment and start targeting where gold naturally accumulates. Stop layers are commonly 1. Bedrock solid, rough, cracked, perfect for trapping gold. 2. Clay dense, sticky, impermeable. Gold can't sink through it easily, so it piles up on top. 3. Hardpack, cemented gravel. Old gravels that have compacted and partially cemented. Gold settles into the stable layer. 4. A false bottom, a layer of tightly packed cobbles that acts like a barrier under certain conditions. And here's why this matters. If you're sampling above a stop layer, your chances of finding gold rise dramatically, because gravity has been doing the work for you for a long time. Bedrock, the king of permanent traps. Bedrock is the most reliable gold storage in a river system because it doesn't move much. But bedrock traps are not random. Bedrock has features that matter: cracks, joints, potholes, shelves, uneven surfaces, ledges, and steps. Gold gets wedged into these features like it's paying rent. And here's the detail most people overlook: crack orientation matters. A crack that runs across the flow tends to trap more than a crack that runs with the flow. Why? Because a crack across the flow acts like a natural riffle. Water drops into it, velocity changes abruptly. Heavies fall in and get stuck. Cracks parallel to the flow can still trap gold, especially if they're deep or irregular. But across-flow cracks are often more efficient. So when you see bedrock, ask, where are the cracks? Which direction do they run? Where is the lowest point? Because gold will tend to collect at the deepest section of a crack, the downstream end of a crack inside potholes and depressions just downstream of bedrock steps, where water slows potholes, nature's little gold vaults. Potholes form when water swirls with rocks and drills into bedrock. They're literally erosion bowls, and they can be amazing traps because they create a low-pressure swirl zone. Heavies settle into the bottom once material packs in. It becomes stable. But potholes also play mind games. Some potholes look perfect, but are cleaned out by high-energy floods. So the best potholes are often in zones where flow is strong enough to form them, but not so violent that they constantly get emptied. Think of potholes like bank accounts. Some get deposits, some get robbed. Your job is to find the ones with deposits. And how do you do that? You sample them. Yes, boring answer, but accurate. Clay layers, the sneaky gold catcher. Clay is like a natural gold carpet. Gold can't easily sink through it, so it piles up on top, especially fine gold. If you dig into gravels and suddenly hit clay, that's a moment where you should sit up a little straighter, because clay often marks an old, stable depositional surface, a boundary where heavies stop a zone that can concentrate gold. But there's a trick. Gold isn't usually mixed inside the clay. It's often sitting right on top of the clay in the lowest part of the clay surface, along the clay wrinkles and depressions. So if you find clay and you just scoop the clay itself, you might miss the real concentrate layer. The best sample is the material directly on top of the clay interface. That's where gold likes to rest. Hardpack, cemented gravels. The pay layer time capsule. Hardpack is compacted old river gravel that has been sitting long enough to become dense and stable. Sometimes it's slightly cemented. Sometimes it's just packed tight. Either way, hardpack is important because it represents an older river surface that has had time to concentrate heavies. Loose surface gravel is like today's weather. Hardpack is like climate. If you can reach hardpack, you're sampling something more meaningful, and pay streaks often develop at or near these stable layers. False bottoms, the trap that tricks beginners. Sometimes you dig and hit a layer of tightly packed cobbles and think, bedrock. But it's not bedrock. It's a false bottom. A false bottom can still trap gold because it acts like a barrier. Gold can settle into the gaps between cobbles. But here's the danger. A false bottom can also hide the real bottom beneath it, and sometimes the real gold is lower. So how do you tell? Bedrock feels continuous and solid. False bottoms feel like a locked pile of rounded stones with gaps. In sampling, if you hit a false bottom, you can still test it, but also consider, is there clay beneath it? Is there real bedrock nearby? Is this a stable layer or just a temporary jam? How a pay streak forms, the big picture. A pay streak forms when heavies are repeatedly concentrated in the same zone over time. That happens when the river has a consistent energy drop in that area. The channel geometry keeps directing heavies into one lane. The bottom surface, bedrock, clay, hardpack, can hold the heavies. Floods rework the deposit, but don't completely wash it away. So pay streaks are not random. They are the result of repeating physics. That's why, once you find a small signal, like a few flakes, you don't just celebrate and leave. You use it like a clue. You test, slightly upstream, slightly downstream, slightly left and right, across the bar. Because you're trying to locate the streak, the line where the heavies actually travel and settle. The upstream chase, how to think like a detective. Here's a powerful strategy. If you find gold in a place or environment, you can often follow it upstream toward the source. Not because you're going to find a nugget behind every rock, but because gold concentration patterns can get stronger as you move toward steeper gradients, more bedrock exposure, more source proximity. However, this is where people mess up. They find gold, get excited, and sprint upstream like a dog chasing a squirrel. Don't do that. Instead, do controlled steps. Sample your current zone to locate the pay streak, move upstream in small increments. Sample again, track whether your heavies increase or decrease. If gold starts decreasing consistently, you may have moved away from the streak or away from the source zone. If it increases, you're getting warmer. This is geology meets detective work. No vibes, just patterns. Personal commentary. the river rewards. Patience, not ego. There's something humbling about bedrock hunting, because bedrock doesn't care how confident you are. It forces you to slow down and pay attention. And honestly, that's where I think a lot of people get frustrated. They want instant reward. But placer gold is not a slot machine. It's a long conversation with gravity. And gravity is the kind of character that never laughs at your jokes. It just does what it does. Now we level up from gold in rivers to the wider world of heavy minerals and gemstones. Because once you understand placer systems, you realize something exciting. Rivers don't just concentrate gold. They concentrate whatever is heavy, durable, and able to survive transport. So a good placer spot can be like a natural treasure sorter. But big warning, this is also where people get absolutely wrecked by shiny things. Because the river is full of stuff that sparkles, and most of it is not going to pay your bills. So in this part, I want to do 3 things. Explain what heavy minerals usually show up with gold, and what they indicate. Talk about gemstones that can appear in placer environments and help you avoid the classic "I found something shiny, therefore I'm rich" trap. Let's go. The river's heavy mineral crowd, gold's neighborhood. If you pan concentrates long enough, you start seeing the same characters again and again. It's like a recurring cast in a TV series. And each one can tell you something about the geology upstream. Here are the usual suspects: black sand, magnetite, hematite, ilmenite. This is the most common. Magnetite, strongly magnetic, heavy black. Hematite can be reddish-brown to black, often less magnetic. Ilmenite, heavy black-gray, sometimes weakly magnetic. Black sand means the river is capable of concentrating heavies. It doesn't guarantee gold, but it tells you this environment can sort dense material, which is like getting to the right neighborhood. You still have to find the right house. Garnet shows up as deep red, brown red, sometimes almost black grains. It's heavy and durable, so it concentrates easily. Garnet can indicate metamorphic rocks upstream, and it's also a signal that the river has enough energy to move and sort heavies. Also, fun fact, garnet is one of those minerals that looks fancy, but is sometimes just everywhere. So don't sell your car because you saw one red grain in your pan. Zircon. Zircon grains can appear in concentrates. Tiny, heavy, very durable. They can be colorless, pale brown, sometimes reddish. Zircon is like the quiet nerd of placer minerals. Not flashy, but extremely informative to geologists. You won't notice it unless you're looking carefully, but it's a clue about rock sources and long-term sediment recycling. Lead looking. Sulfides, sometimes. Depending on local geology, you can see heavy sulfide minerals. Sometimes they're present with gold-bearing systems, sometimes not. The point is, when you see a dense, metallic-looking concentrate, it's worth being curious. But this is important. Metallic-looking does not mean valuable, which brings us to the villains. The shiny liars, what fools beginners. Most often. If you're new, you will see sparkle and think, gold. That's normal. Your brain is basically wired to react like a crow. Shiny, take it. But the river is full of shiny. Let's talk about the 3 classic liars. 1. Mica. Mica flakes sparkle like crazy. It can look exactly like fine gold if you don't know the difference, but mica behaves differently. Mica is light, it floats and dances. It breaks into thin sheets. Gold is heavy. Gold settles fast. In a pan, mica will often stay spread out, flutter and move. In weird ways, sit on top of heavier material. Gold will drop to the bottom, collect with black sand, stay put when you gently swirl. So if your gold is sparkling everywhere like glitter at a kid's birthday party, that's mica. And I'm sorry. 2. Pyrite. Fool's gold. Pyrite can look goldish, especially in bright sunlight. But pyrite is brittle and often forms cubes or sharp grains. Gold is malleable. If you crush pyrite, it shatters. Gold flattens. Also, pyrite often shows in rock, not as stable flakes in river concentrates, though it can appear as grains. Pyrite is not worthless as a geological clue. It can indicate hydrothermal systems. But in a pan, it's mostly just there to humble you. 3. Chalcopyrite and other sulfides. Some sulfides have a gold-like tint. They can be heavy too. But again, heavy plus shiny gold. Your best friend is behavior in the pan. Gold behaves like it's tired. It settles and refuses to move. Shiny liars behave like they had 3 energy drinks. Gemstones in placer environments. Yes, it's real. Now here's the fun part. Placer systems can concentrate certain gemstones because gemstones often have high hardness durability and enough density to settle. This is why some of the world's famous gemstone deposits are placer deposits. And depending on your region, you might encounter garnet as a gemstone. Sometimes garnet grains are just abrasive minerals. Sometimes they're actually gem quality crystals. But gem quality is usually clearer, better formed, less fractured, better color, sapphire, and ruby corundum. Corundum is hard and can survive transport. Placer sapphires exist in many places. They can appear as rounded pebbles, sometimes with dull surfaces, until cleaned. And here's the heartbreak part. You can find corundum and not know it, because rough sapphire often looks like a sad pebble, not like jewelry. So if you're in a region known for corundum, learning basic recognition matters. Spinel can occur in placer environments too. It can be red, pink, blue, black. Again, rough spinel can look boring until you wash it and examine it properly. Topaz, tourmaline, zircon, gem forms. In some environments, these show up as well, but it's highly location dependent. Some rivers are heavy mineral rich. Some are basically just quartz and sadness. So don't expect gemstones everywhere. Expect them where the geology supports them. How to think like a geologist without pretending you're one. Here's the practical mindset. If you find certain heavy minerals, ask, what rocks upstream could produce these? What does that say about the mineral system? Does this environment match gold formation types? For example, lots of quartz gravels plus iron staining plus sulfides in the area might suggest hydrothermal veins upstream. Lots of black sand and garnet could suggest energetic sorting and metamorphic source rocks. Corundum suggests specific metamorphic or igneous conditions depending on region. Now, I'm not saying you need to memorize a mineralogy textbook. I'm saying use clues. Rivers are like crime scenes. Minerals are fingerprints, and you're basically the detective. A muddy, slightly sunburnt detective with a pan. The biggest mistake, confusing indicator with proof. This is where I want to be very direct. A lot of people see one clue and declare victory. They see black sand and say, this place has gold. They see quartz and say, this place has gold. They see rusty rocks and say, this place has gold. And sometimes they're right. But geology doesn't work on single clues. Geology works on systems. A clue is not proof. A clue is an invitation to test. So the correct thinking is black sand, yes, this spot can concentrate heavies. Quartz, yes, there might be hydrothermal veins nearby. Iron staining, oxidation and mineralization might be present. Garnet, heavy minerals are being sorted. Metamorphic sources possible, corundum. Gem potential depends on region and source rocks. Then you sample, compare, and build a pattern. That's how you stop being fooled by sparkle. Personal commentary, because I've been fooled too. Let me embarrass myself real quick. I once found a pan full of sparkles so intense, I actually laughed out loud. I'm talking full Disney princess glitter effect. My brain went, this is it. This is the moment. I showed it to someone more experienced. They looked at it for 2 seconds and said, nice mica. That's the day I learned. Nature doesn't care about my emotions. It will let me get excited. It will let me film close-ups. It will let me imagine thumbnails. And then it will quietly remind me that I'm still learning. So yeah, if you've ever been fooled by shiny things, welcome to the club. The club is huge. Now, we stitch everything together into something you can actually use every time you go out, whether you're hunting gold, checking for gemstone potential, or simply trying to understand what the land is telling you. Here's the real goal, not to become a lucky panner. The goal is to be the person who can walk up to a river and think, I know what this system is capable of. I know what to test first, and I know when to leave. That's how you stop wasting time. And honestly, that's when this hobby becomes addictive. Because once the river starts making sense, it feels like you've unlocked a secret language. So let's build a complete strategy. The prospecting blueprint: simple, repeatable, reliable. Step 1. Ask the only question that matters. Before you even touch your pan, ask, does this drainage area have a gold source, or at least a heavy mineral source, somewhere upstream? You don't need to be a professional geologist. You just need to think logically. Are there quartz veins in the area? Is there iron staining and signs of mineralization? Is the region known for gold, gemstones, or heavy mineral deposits? Do you see evidence of old river gravels, terraces, or hardpack layers? Do you already see black sand or other heavy minerals? If the answer is no clue, that's fine. Then you're exploring, not expecting. Exploration is valid. Just don't confuse exploration with guaranteed results. Step 2. Read the river like a physics problem. Now scan the river and ask, where does the river lose energy and where does it gain energy? Energy drop zones are where heavies settle. Look for inside bends, but focus on microzones, not the whole bend. Behind boulders, shadow zones. Natural riffles, rough bottoms, cobble fields. Transitions in gravel size, big to small, is a slowdown clue. Bedrock exposure, cracks, steps, potholes. Places where fast water becomes slower water, especially where the channel widens. The downstream side of obstacles and small drops. Remember the golden rule. Gold doesn't care about beauty. Gold cares about stability. Step 3. Find the stop layer before you chase the dream. Don't start by sampling loose sand. Look for a layer that gold can't sink past easily. Bedrock clay, hardpack or cemented gravel. False bottoms, tight cobble layers. If you can't reach a stop layer, you can still sample, but treat it as surface information, not the final truth. The top layer is the river's mood. The bottom is the river's memory. Step 4. Use the 3 sample rule. And stop judging with one pan. Take a surface sample, a mid-layer sample, and a bottom sample. Then compare the heavies. The question isn't, did I find a nugget? The real question is, are heavies increasing toward the bottom? And are black sands or dense minerals concentrating here? If yes, that's signal. If no, you move. No emotional negotiations with the river. Step 5. Locate the pay streak. Don't guess, scan. Once you have signal, don't camp in one spot forever. Scan across the area. Sample in a rough line across the bar or across the bend. Where heavies are strongest, tighten your sampling around that point. That's how you locate the pay streak, because pay streaks are often narrow. 2 steps away can be nothing. Your job is to find the lane where the river keeps dropping dense material. Step 6. Follow the pattern, not the hype. Now you decide, stay, move, or mark. Stay. If you're seeing heavies increasing with depth, consistent black sand streaks in layers, any gold color at all, bedrock cracks. Holding concentrates, a clay interface with dense material sitting on top. Move. If the area is uniform, loose sediment, no heavies, no structure, no clear energy change zones. Mark it if it looks promising, but conditions stop you. High water, too much overburden, safety issues. You can't reach the bottom. Mark it and return later. This one habit alone makes you smarter than most people who try gold once and quit. The don't get fooled checklist, quick reality filter. When you see sparkle, run this test. Does it settle like gold? Gold drops and stays. Does it move like mica? Mica dances, floats, spreads everywhere. Is it brittle like pyrite? Pyrite breaks and flakes differently. Is it sitting with heavies? Gold typically lives with black sand and heavy concentrates. Sparkle alone is nothing. Behavior is truth. Closing. Let me end with something honest. Gold hunting, gemstone spotting, and reading geology sounds like a hobby, but it's also a mindset shift. It forces you to slow down and see the world differently. Most people walk past a river and see water. Over time, you start seeing erosion, deposition, energy, history, hidden layers, and clues. You realize the landscape isn't random, it's a record of processes, and every time you scoop a pan of gravel, you're basically asking the earth, what have you been doing here for the last 1,000 years? Sometimes the earth answers with nothing. Sometimes it answers with a few tiny flakes, just enough to keep you curious. And that curiosity is the real treasure. Yeah, that sounds dramatic, but it's true.